Hi, I'm Mudinda and I'm here to help you understand maths better for free. Grade 12s, today we're going to be talking about what a derivative is exactly and also what stationary points are. This video is part 5 of our grade 12 calculus video series, so make sure that you've watched the first 4. Let's get right into it. A derivative is the gradient of a function. When we ask you to find the derivative of a function, we're actually asking you to find the gradient of that function. Remember, gradient means how steep a function is. It's the slope of a function. When we talk about the slope of a straight line graph, such as this one over here, you will note that it is equally steep everywhere. So the gradient is constant. If you were this blue guy over here and you wanted to walk from this point here to the next point there, that would be as difficult if you were the red guy wanting to walk from that point there to that point there, right? The steepness is the same all across this line. The gradient is the same all across that line. So f prime of x there is a constant number. The gradient of a straight line is a constant. The parabola graph, however, is a bit different. It is not equally steep everywhere along this graph. It's definitely not equally steep. If you were this blue guy there and you were trying to walk along this graph, let me make this guy's feet a bit bigger. It would be a bit easier to walk up than if you were the red guy over there, right? It's a bit steeper to walk up there than it is to walk up here. This is a bit of a more gentler slope than that one is. Okay, so that's why we say here that some parts of this graph are steeper than others, right? The guy who's red there would find it more difficult to walk up than the guy who's blue there. The gradient is not the same everywhere, and so the first derivative is not a constant. Okay, each point on this graph has a different gradient to another. So every single point on this graph has a unique gradient. Some parts are steeper than others. Some parts are more gentle than others. All right, so just remember, matriculants, by the way, that the notes to these videos are linked in the description of every single video. In the description of every single video, I will put a link that leads you to downloading the notes. So if you want to have a look at these notes, feel free to download them below. Now, since the gradient on a parabola is different at every single point, how do we find the gradient at a particular point? How do we find the gradient at each point of a parabola? Remember, like we said, the first derivative is the gradient. So if you had, for example, this graph here, which is the graph of f of x is equal to x squared minus 4, if you wanted to find its gradient, you would derive f of x. F prime of x is equal to 2x, right? This f prime of x of 2x is the equation that represents the gradient of this graph at different x values. So whatever x value you can plug into that, you will get what the gradient is at that x value. For example, if you are asked for the gradient at x is equal to 1, you would say, well, the gradient at x is equal to 1 is equal to 2 times 1. Okay, and maybe to make this a bit more clearer, let me start by saying, remember, f prime of x is equal to 2x. So f prime of 1 would be equal to 2 times 1, which is 2. So the gradient at an x value of 1, let's say this was the x value of 1 here, the gradient there would be 2. M, or f prime of x, would be equal to 2. Okay, what about the gradient at x is equal to 5? The gradient is represented by f prime of x is equal to 2x. So the gradient at an x value of 5 would be 2 times 5, which means it would be 10. So at an x value of 10, let's say somewhere there, x value is 10. The gradient there, m, or f prime of x, is equal to 10. And you would agree with me that the pink point there is much steeper than the green point there. It would be much more difficult for you to walk up that hill than it would be for you to walk up this hill. And that's why the value of f prime of x at the pink point is 10, but at the green point it's 2. So the gradient is bigger at the pink point than it is at the green point. I'd say here that m at the green point is much less than m at the pink point. Okay, or f prime of x at the green point is much smaller than f prime of x at the pink point. Okay, so that's how we find the gradient at each point of a parabola. Now have a look here. We're told that f of x is equal to x squared minus 3x minus 10 and asked to determine the gradient at x is equal to 3. We would say, well, f prime of x, the gradient or the first derivative, is represented by 2x minus 3. And so the gradient at an x value of 3 would be 2 times 3 minus 3, meaning it's 6 minus 3, meaning that it's 3. Okay, so the gradient there would be 3. But what is the y value when x is equal to 3? Well, to find the y value, we know f of x, or the y value of any x, is x squared minus 3x minus 10, right? And so the y value there, we can find it by just plugging in 3 into the original equation. Remember, this equation, if you give it an x value, it spits out the corresponding y value, okay? But this equation, if you give it an x value, it spits out the gradient at that x value. Okay, that's the difference between f of x and f prime of x. Okay, now this is 9 minus 9 minus 10. So negative 18 minus 10, which is negative 28. Okay, wait, no. 9 minus 9 is 0. And 0 minus 10 is negative 10. So the y value when x is 3 is minus 10. The gradient when x is 3 is 3. Okay. Plugging in an x value into the f of x equation gives us the corresponding y value. Plugging in an x value into the f prime of x equation gives us the gradient at that point. Let's look at another example here. This one says, at which point is the gradient of f of x equal to 2? Okay, so f of x is equal to x squared minus x minus 12. Let's find the equation of the gradient of f of x. That would be 2x minus 1. Now the question says, at which point is the gradient equal to 2? So I'm going to replace this with 2 to find the x value that has a gradient of 2. Okay, so then I get 2 plus 1, which is 3, is equal to 2x. Divide both sides by 2, and I get that x is equal to 3 over 2. What does this mean? When x is equal to 3 over 2, f prime of x is equal to 2, or the gradient is 2. Right, I hope this makes sense. Now, this brings me to something really important, and that is stationary points. Now, stationary points aren't actually new. We called them turning points back in grade 11. In grade 12, we call them stationary points. It really is just the same thing. But there's a very important concept you now need to be very, very confident with. It's the fact that at a stationary point, the gradient is equal to 0. Now, I'm going to use a method that we used last year to find the stationary point. Then I'm also going to use a method we use this year. If you wanted to find the stationary point of f of x here, where f of x is equal to x squared minus 4x minus 5, you'd start by finding the first derivative, f prime of x, and that would be 2x minus 4. Now, at the stationary point, we said the gradient is 0, okay? At the stationary point, the gradient is 0. So if you want to find the stationary point, replace f prime of x, the gradient, with 0. I'm going to solve for x here. Divide by 2 on both sides. I get therefore that x is equal to 2. What does this mean? This means when x is 2, the gradient is 0. In other words, this is the x value of the stationary point, because at the stationary point, the gradient is 0. How can I find the y value of the stationary point? Easy. Plug in the x value into this equation. This equation will always spit out the corresponding y value if you give it an x value. So we put that 2 squared minus 4 times 2 minus 5. This is 4 minus 8 minus 5, which is negative 4 minus 5, which is negative 9. So the stationary point is at 2 and negative 9. Now I just want to prove this to you using a method you learned last year. You said the x value of the turning point is always equal to negative b over 2a. This was the formula that we used to find the turning point in grade 11 when we were doing functions. So b is negative 4, so this is negative into negative 4, 2 times 1. The answer there would be positive 4 over 2, which is 2. So the x value of the turning point is 2. And you can find the y value of the turning point by plugging in 2 into the equation there. And again, you'd get negative 9, meaning that the turning point would be 2 to negative 9. So as you can see, both methods land us on the same stationary point. But very important for you to know that at the turning point, at the stationary point, the gradient is equal to 0.